Hello everyone, welcome to the afternoon sessions of WeCap 2020. It's Gregor Wolf again, and I have the pleasure now to introduce Marc Becker and Adrian Görler to you. So they're both are with SAP. Marc Becker started in 2012 as a dual student, and before CAP he was working with SAP HANA XS Advanced. So perhaps we can also ask him questions regarding how to deploy CAP to XSA, and is also now working on the SAP Cloud Platform, Cloud Foundry. Adrian Görler, he is really long with SAP since 1999, so 21 years already, and was part of the ABAP language team and moved then into the OpenSQL section for Java and is a member of the JPA 2.0 expert group. So, and without further ado, I hand over to you for your session now, which is the new modularized CAP for Java.
Okay, so thanks for the introduction. Let me share my screen. So when we sat together and discussed what we wanted to present here, we were asked to, talk about and showcase the modularization features of the next generation CAP Java stack. But we thought that not everybody, like in the audience, would be familiar with the next generation CAP Java stack, and also with the fact that there is something like an old and a new CAP Java stack. So overall, this is the agenda which we compiled for this meeting. So we want, as suggested, start with explaining what the next generation CAP Java stack is about. Then we want to give some a walkthrough through the publicly available Java sample application, which really showcases most of the features which we have there. Then we want to go in theory a bit again and discuss the fundamental building blocks which allow us to leverage modularization in the CAP Java stack. And then maybe the most interesting part, then we leave the world of slides and go into 3 different examples of where you can use modularization features of CAP in Java. And then we plan to summarize, sum everything up a bit, and talk about other features which allow us where modularization comes into play to leverage features of the platform. So what is the next generation CAP Java stack, which is officially named the CAP Java SDK?
Adrian, before you continue, it seems that on your stream, or on your computer, the stream is also running. So can you mute that?
I will check this. Yes, I will just switch it off. So hopefully it's better now.
We will check, and you hear if it isn't. Thank you.
Okay, so the offering we used to have for CAP in Java about 1 year ago was called the SDK for service development. This is what the architecture of the CAP of the SDK for service development roughly looked like. So it basically was a 3-tier architecture. It allowed you to basically auto-expose a CDS model, automatically handle requests against the HANA database, expose the service definitions as OData services, which could be consumed from the Fiori UI. This had some shortcomings. For example, the service SDK does not really have an API which allows you to consume other services from Java, so this was completely missing. And also it did not offer something like a uniform query language. So if you wanted to, well, compose queries which reach out to a HANA database, you would have to do this differently as opposed to composing queries which were targeted against a remote OData service. Then OData was really, really hardwired as a protocol in the service SDK. It was even like, well, even the case that, well, the large parts of the implementation are actually existing twice, once for the OData v2 and once for the OData v4 protocol. Then the service SDK was really targeted and limited also to request handling, and well, things like message processing were not so easy to integrate there. And then, of course, we had a log into HANA. Firstly, there was CD-SQL leveraged as the query language on HANA. Now this has been lifted, this limitation a bit, so it is also possible to execute HANA-specific SQL if you want to run on the HANA Cloud Edition. And finally, support for Spring was kind of retrofitted into the service SDK. It has not been like designed to run with Spring, and and this leads to some issues which are really hard to solve, especially in the area of transaction handling. So overall, at the beginning of last year, we came to the conclusion that we want to well, leverage so many new features in Java that it's not really possible to like refactor the existing Java stack in a well to support all the new features, but that we really should rather start with building something new from the scratch. And this is what we started to do at the beginning of last year. And the first version we made available with TechEd last year. This is what we call the CDS Java SDK, or the next generation Java stack. So in the next few slides, I want to like illustrate how the architecture evolved. So we came from this hardwired 3-layer architecture where we basically had a service layer which could only expose OData or talk OData as a protocol, and downstream only automatically expose services which are persisted on a HANA database. And the first, well, not very brilliant idea, of course, was to decouple here, to introduce something like a protocol adapter, which would allow us then to well, to make the service layer itself protocol agnostic, so it does not directly understand OData requests any longer, but instead it now supports requests which are written in, well, in our uniform CDS query notation called CQN. And of course, the same is possible to do well downstream. So also we did a decoupling here and introduced something like a data source adapter, in particular one for HANA. So overall, what we fundamentally did, we made the service layer now complete agnostic of EDMX. It does not know the EDMX model any longer. This is the knowledge that services are exposed of OData completely resides in the so-called protocol adapter, and also downstream the service layer also is only using the canonical CDS query notation, CQN, and the task to translate then CQN to the particular dialect of the data source, this is handled by a data source adapter. And now once we have this architecture, this opens many doors, because you can basically introduce new adapters for like well, for example, downstream to talk to a remote OData service, or you could introduce a REST client protocol adapter, and then the service layer is completely protocol agnostic. It does not know anything that there is OData or that there is REST or other protocols which might there be. And also downstream, it just does not know that there are databases. Well, of course, it integrates with transaction management, and if the data source adapter happens to be transactional, then it can leverage this, but it does not do anything HANA specific or anything OData specific any longer. And this is basically the architecture which we are currently having in the next generation Java stack. And having, well, explained this, I would like to hand over to Marc, who, well, will give us a walkthrough through the CUP Java sample application.
Yeah, thank you, Adrian. So what I want to do now is I first want to introduce you to the CUP Java sample application, which we have just released 2 weeks ago on github.com, finally. So you can find this in the SAP samples organization. And there, similar to what Daniel also showed in his keynote, we now have a sample application also for Java. And I want to now show you some of the highlights that we showcase in this sample application to also give you an understanding of what features we already support out of the box in Java. So let me switch to my code editor. First of all, I want to show you the CDS model. That is the baseline for this project. So we have here a rather simple CDS model with 4 entities. We have the entity books. We have the entity authors, orders, and order items. This is kind of similar to what we also showcase in the Node.js example. But as you can see, we are already using all the great features from CUP, like localization for text and Fiori draft, and also using sub-CDS common and all that great stuff that we provide there. We also expose these entities into services. The first service is the catalog service, which we expose, where we expose a simple view on the books entity. And we have a little bit more complicated admin service here that, for example, also shows how you can add an action to an entity, how you can require authentication for your service, how you can enable deep search capabilities to, in case of search, really follow also along associations. You will also see that in action in a second, and also which is leveraging the Fiori draft support that we provide in CUP out of the box. So let me quickly start this application. What we have also done in CUP Java is we are also now leveraging locally, when running locally, SQLite. So currently my application is running with an SQLite in-memory database. And I can now switch here to the Fiori UI that we have as part of this app. It shows you the 3 tiles that you also might know from Node.js already. So, for example, we have here the Browse Books UI, which basically shows you a list of all the books that are available. This is now data that is served from also the CSV files that we have in that application. So some example data is also already automatically part of that application. And we can also have a look at this little bit more complex UI here. So we have here the Create Order UI, which allows us to run the full Fiori draft flow. Basically, we can create here a new draft. We can here create a new order. We can select the currency here, for example, using the value help. We get here, for example, this created by, changed by. This is automatically filled in by CUP using the managed aspect, which you also might know already. And here we can now add an order item. For example, the book Wuthering Heights, and we want to order it once. And you can see that this also shows some business logic. For example, here we calculate the net amount of an order item and the total order value. So if I, for example, now change this quantity to 2, those two values change here. And if I add another book, let's say, for example, The Raven, this also applies here to the total order value that we have above here. Let's save this. As said, this is a draft entity, so you can also go into edit mode here and also resume editing later on. But what I want to show you now is the search capabilities. As you've seen, we ordered the book Wuthering Heights and The Raven on this order. And now, for example, here on this order UI, I can search for Wuthering. And when I click go here, actually it filters down to only those orders that are ordering this book Wuthering Heights. For example, if I'm looking for The Raven, this is actually only ordered. Oh no, actually this one also. Sorry. Here. Yeah, so this one also is only ordered by our new order that we just created. Another cool thing is the localization support that we have in CAP out of the box. So for example, if I change my browser language, my primary browser language to German now, I can actually refresh this page here. And now the whole UI is in German. We also show that in our sample application. So the static texts on the UI are in German. If we have a look here at the data from the application itself, this is also localized, like here, Wuthering Heights now translated into Sturmhöhe, but also, for example, the dynamic messages, like if I say I remove this mandatory field here and I save this. Oh, actually, I still get English. Sorry about that. It's probably because I need to refresh the application. But here, for example, I get an error message now in German. And this, for example, also affects the search. So if I, for example, now search for Sturm, I also find again those orders that were ordering the book Sturmhöhe or Wuthering Heights. Let's look into some code actually to see what powers this. So I will change back to VS Code, and there let's have a look at our server module where we have the Java code in there. You can see there's a POM XML, which makes this a Java project. And as you know, in CAP, every custom logic that we want to add to our application is implemented in so-called event handlers. And as you can see here in line 27, in Java we use an annotation-based approach to register those event handlers. So what this basically says here, I want to register an event handler on the after phase whenever the read event is triggered. After read means that I have already access to the data that was read from, for example, the database. And here in the method signature, I want to get access to the stream of books. And we can automatically infer from that we only call this event handler whenever the entity books is read. Another cool thing that you can actually see here is there are these interfaces. And these interfaces are automatically generated for you based on the CDS model. So in CAP Java, we actually provide you with a type-safe access to your entities. You can see, for example, here now on the book property B here, you can now use the methods getTitle or getStock to really access the properties or elements of your entity in a type-safe way. Here, for example, we look for all the books that have a stock that is over 111, and if we if the stock exceeds that number, we add to the title here the 11% discount, which is just a very simple business logic, but it already shows how this can be used. If the stock here is not available, we try to read it from the database. This can be, for example, the case when it was not part of the selection from the UI. And you see here, we are using the DB variable, and this comes from line 25. And there we are using the auto-wired annotation, which is a Spring annotation, to inject the dependency for a persistent service into our event handler. And this basically shows that when we are running in Spring with CAP, the event handlers are Spring beans, which means they can leverage the full power of Spring. You can use dependency injection and all the other cool features that Spring provides, just as an addition to everything that CAP provides you. So you have a huge ecosystem that already has a lot of great stuff built, and you can just use it as well. So we do not do anything that does not work anymore. And so we are actually using here now the persistent service, which is just another service in CAP that encapsulates the database. And we can run CQN queries to this service to, for example, here in this case, retrieve the book stock from the database. And in this select statement that you see here, we can also see that in CAP Java, we have a way to type in a type-safe way also construct these queries. For example, here we know that we are selecting from books, so we know that we can select a stock, for example, and this makes it really easy to avoid any tedious mistakes that you might have mistyped something, or if you do changes to your CDS model, especially very beginning of your development. What we also show in this bookshop that's pretty nice that I want to show you is how you can write tests for your event handlers. One way is to use Spring Mock MVC, which basically provides a really nice way to run and write API integration tests. So what this does is Spring actually completely runs the server, your HTTP server in memory, and basically mocks the HTTP server for you. So you can run HTTP requests using this mock MVC pattern and test for certain responses in those HTTP requests without the actual need to start up an HTTP server and have the network overhead in your tests. And this makes API integration tests with mock MVC really fast. And this is just one of the nice things that we just get from Spring for free. Of course, you can also write completely standard JUnit tests. And as you saw here, for example, I'm testing the catalog service handler that we just saw earlier, and its discount books function. And because we have these flexible method signatures where you actually directly only request what you need in your event handler, for example, here the stream of books, you can also easily test them without having to mock a lot of stuff that you actually are not interested in. One last thing that I want to show you is how we also make use of Spring's configuration possibilities. So also we ourselves in CAP put all our properties that you can use to configure the CAP Java application. We model them as Spring properties, so you can use the full Spring configuration means like profiles and stuff like that to configure your CAP Java application. For example, here you see how we, for example, configure mock users for our Java application. Yeah, and with that, I would like to hand over back to Adrian, and yeah, we will see also this application later again in our other demos, because they are basically based on this app. But this was just the brief overview, so feel free to check out the GitHub repository yourself and yeah, have a look at this application. And with that, back to Adrian.
Unmute my mic. So can you see my screen again? So let's check.
Not yet. Just your camera in for the moment.
Yeah.
And just an information also to all the ones on the stream, please post your questions, because we are collecting them and then doing the Q&A at the end.
Okay. I think you should now see my screen again. So let's talk about what are the fundamental building blocks which allow you to leverage modularization in the CAP Java stack. So this is the architecture which I just sketched. And if you have a look here, we find like something like a repeating pattern. We do have this green box here, the service layer, and it understands the CQN. It reflects on a CDS model, and it can reach out to custom handlers. And this is basically the most fundamental building block or architectural pattern which we use here in the CAP Java architecture. If we, well, depict this like this, this is basically what makes a service. So as Daniel also mentioned this morning in his keynote, a service, that's the only active component in the CAP stack which really does something. And it can be defined. The service definition can be captured in the CDS model, but that's not even necessarily the case, but very typically it's the case. The language which it understands, which we use to express queries, that's the canonical CDS query notation, or CQN. So it understands all CDSQL queries, and it actually is capable of dispatching then, well, events which are also expressed in CQN, but also contain some additional information, like some additional context information. It can dispatch then these events to so-called event handlers. At the beginning of our architectural work here, we thought that we had a distinction. We had something like auto-exposed services which would directly talk to downstream services to do basically that business. But we then identified and we had like custom events which were implemented as breakout points or callbacks, which were then called from the service. But we, at some point in time, identified that the architecture would be very much clearer and very much simpler if we would also implement all generic logic as event handlers of services. And this is what the current fundamental building block of our architecture looks like. So we have a service, which is the active component. It understands CQN as the canonical query language, and it just dispatches then the events to event handlers. We have some generic built-in event handlers which we offer as part of the SDK, and they can then be augmented with custom handlers. We have the well-known annotations before and after, which would allow to, break out and call your custom event handler before or after something which is generically handled by the framework. But we also allow you with an on-handler to completely replace the generic handling with something which is more appropriate to your business case. So just to summarize, basically, services are active components and they are defined by the set of events which they can handle, and on also by how these events are handled. But all event handling is now implemented in event handlers. We do not distinguish between, well, built-in generic event handlers or custom handlers. They're all treated in the same way by a service. It only depends on well, the annotation before or after of the which is used to register custom handlers, whether you do completely with generic logic or whether you replace it completely with something which is custom implemented, or whether you want to augment or intercept the invocation with your custom handler. So these are the most fundamental building blocks: services, events, event handlers, and service consumers, and of course the CDS model. Now, if we only depict this, people are of course asking, well, how does the overall architecture of the Java stack look like? Because this is a bit like telling nothing. So this is also a bit a rough sketch of the architecture of the next generation Java stack, but now really using here the event handlers. So we have built in the OData protocol adapter, we have built in the CDS service layer, where all the CRUD events are automatically handled by event handlers, which then call out to the downstream persistence service, but where also all custom events are typically registered as event handlers of the CDS service. And these custom event handlers, then they can, as we have seen, for example, in the example just showed by Marc, where well, where he showed it is an event handler which granted this 11% discount. This reached then again programmatically out to the persistence service. But as your custom handlers can do whatever they want, they could also reach out to some other service, and well, then the event handlers of this other service would be triggered, for example, or they just do whatever they want. The persistence service again is implemented with event handlers. It does not much, the persistence service. It does things like generate your UIDs, for example, or it handles this managed aspect where the created at and modified at timestamp is set, things like this. But the most important part of the persistence service is, of course, that it reaches out to the downstream data source to actually implement the CRUD operations. But it's still nevertheless possible to register custom handlers here in the persistence service to override the default implementation of the persistence service. We will see an example of this later. And the last fundamental query block is, of course, CQN. Actually, CQN is just one notation of what we call CDSQL, which is the query language of CDS. There are other representations of our query language. There's also the CQL notation, which I have put two examples up here. But there are also, of course, other representations, like, for example, in the Java stack, of course, you do not have to work directly with CQN, but we have a set of interfaces which represent the CDSQL queries in Java, and which you work with if you implement your well, the custom logic of your event handlers. In the example just showed by Marc, for example, he composed a query and which was then represented as a CQN select in memory. So the universal thing is that we talk CDSQL as a language. So CDSQL has some interesting properties which I at least would like to quickly mention is that queries can be very SQL-ish, like this one here. I mean, the only difference here from an SQL query is that in SQL you would find the select clause here between select and from. But besides this, you can use you can write SQL-style queries with, I don't know, using joins and subqueries and whatever you know from SQL. But CDSQL queries can also be can also have an XPath style where you work with infix filters and with path expressions, and so this makes CDSQL very powerful because this XPath style, for example, corresponds very nicely to what you find in OData URIs, whereas the SQL style corresponds very nicely to what you find on a relational database. And it's maybe this power of CDSQL that you can express your queries in these, well, very well complementing styles, which makes CDSQL very expressive. In Java, we have basically two APIs to compose queries, which you have to do if you work with, if you implement your custom handler code. One is the query builder API, which allows you basically to, in a fluent style, compose a query. We will learn more about this in the follow-up session in the part presented by Matthias. But we can also, if you happen to have your query, well, in this CDS query notation, which is basically a JSON representation of the query, then we also have a parser which allows you to parse it. Okay, so these are basically the 5 fundamental building blocks. We have services, events, event handlers, we have service consumers, and we also have CQN or CDSQL as the universal query language. And now I would like to hand over to Marc again for the first demo.
Thank you, Adrian. So, yes, as Adrian just mentioned, one of the key components of CAP are the protocol adapters, and by default we offer a OData v4 protocol adapter in the next generation Java stack. But to really prove the point that you can write and bring your own protocol adapter, we have exclusively, so to say, for this event, built a demo that composed a very simple but already very powerful GraphQL adapter. For those who don't know what GraphQL is, GraphQL was invented from Facebook, I think in 2012, and it was open sourced in 2015. And the definition on their website says that GraphQL is a query language for APIs and provides a complete and understandable description of the data in your API and gives clients the power to ask for exactly what they need and nothing more. And if you're already familiar much with CAP or CDS, you might this might sound a little bit familiar to you, because actually in CAP we also have a query language for our APIs, and we also have a complete and understandable description of the data in our APIs, namely the CDS model, which provides our description, and the CQN statements that Adrian just talked about earlier. So actually we can map these concepts from GraphQL to CDS pretty nicely. On the left side here, you see how a GraphQL query looks like. The query says that it wants to run the query get books, and from the data it wants to select title, the price, and from the currency it wants to select the code. So this is a nested selection here. How a response to that query looks like can be seen in the middle. Basically, yeah, it gives this data structure.
Mark, unfortunately, I have to interrupt. There is again the flickering issue on the Twitch stream, and it seems to be caused by the full screen
Presentation mode.
PowerPoint. Yes, please go to this mode, and hopefully then we get rid of the issue.
Then we do professional PowerPoint presentations with
Yes,
this mode. Okay,
we do it by intent, not by mistake.
Right. We tried the other way around.
Let's see. I'm watching the screen. There is quite a delay until the changes get up here, and let me give you the go when it's okay. So yeah, perfect. Flicker stopped, and please continue.
Okay. Yeah, so here on the left, you see the GraphQL query, and in the middle, you see what a response to that GraphQL query might look like. As you can see, the structure of the query and the structure of the response are pretty similar. And on the right, you actually see the GraphQL schema, which defines certain types. It defines one special type with the name query. This basically defines all queries that you can run. And here we have the getBooks query, which returns an array of books. And we have the two types, books and currencies. They basically have certain properties of certain types. And the currency property of the books type is an association, so to say, to the type currencies. So this can, the CDS model can be easily mapped to this, because actually our entities in the CDS model can be mapped to these types, and then we just need to define some way to create queries on top of that. And I want to show you now how this might look like. So I've switched to a different branch on our bookshop example. And what I had to do now actually to introduce this GraphQL protocol adapter is only adding those 4 classes here that I want to show you now in a little more detail. I did not have to do any changes to my CDS model, to my services, or anything else, because here we actually really only introduce this protocol adapter, which sits on top of everything. So let's start with our GraphQL configuration here. I'm using the official GraphQL Java APIs that you also find on the GraphQL website, and I'm using their Spring integration. So with that, I only have to provide a GraphQL bean in my Spring application, and then this library already takes care of all the wiring for me. It automatically opens an HTTP endpoint at /GraphQL, where I can send my GraphQL queries to. The only 2 things that I have to do is I have to create a GraphQL schema, because this is required by the library. And I also have to define how I want the data to be fetched. But first, we have a look at the schema generation. So in line 23, we actually turn our CDS model, for which we also have a representation in Java, a reflection API on that CDS model. We turn that into a GraphQL schema by using this GraphQL schema generator, which I will show you in more details. Basically, what we do there is for each entity that we expose in a service, we generate a GraphQL type, and then we also generate this GraphQL special type query. I will show you how this is generated in a second. For each entity, as said, we will simply build a GraphQL type. We need to do some type mappings here. For example, GraphQL does not like dots in their entity or in their type names, so we have to transform dots to underscores, for example. And we have to generate all the elements of the entity into the type, where we also have to do some type mappings, because the default types that are available in GraphQL and in CDS are a little bit different. But this is not so much interesting. It's pretty easy to map this. If you want to see the details, you can also have a look at this code after the session. And then we also generate 2 queries for each entity that we explicitly expose in our service. So first we generate an by ID query, and then we also generate an all query. This is basically now just defined what I did here. You could also do it differently. Basically, these two queries define, first of all, the generate by ID query. It's a query that looks like this: get entity name by ID. And GraphQL also has a concept of arguments. And basically, I turn the entity keys here into arguments of that query. And with that, I have a query that can return a single entity identified by its keys. And we also generate here an all query. So get entity name. This basically just returns an array of all the entities that are available. So this is a pretty simple mapping from our CDS model to a GraphQL schema. What GraphQL also needs is a way to know how to fetch the data. In GraphQL, you can actually register data fetchers on all kinds of levels. You can register data fetchers on queries, you can register them on types and on elements. But in our case here, we can basically directly turn the top level query from GraphQL into a CQN statement. So we just register one default data fetcher, our CQN data fetcher, which basically handles every query. And this CQN data fetcher is also aware of the CDS model, and it is also aware of the service catalog, so of all services that we have in our CAP application, which we would like to serve via our GraphQL protocol adapter. And basically also here again, we don't need much code to make this work. Basically what we do, whenever we get a query from GraphQL here, we turn the GraphQL type that is queried into the corresponding CDS entity again. And then we build a CQN select statement from it. We select from the corresponding entity and we generate a path expression with an infix filter that Adrian previously showed. So basically what this does is just it reads the arguments to the GraphQL query and turns them into key conditions that are passed as a filter to the CQN statement. And after that, we also need to define what we actually want to select. You can see that in line 44. There we fill in the columns that we want to select. And also we do this based on the queries, based on the GraphQL query. So what is part of the selection set in GraphQL. How we do that is, as you saw, back to the presentation, here a GraphQL query consists of certain elements that or selected fields, so to say. And sometimes these can be nested. And in that case, it's basically an expand in OData. In OData, this would be an expand, for example, or it's in our CQN statement, or you can basically say this is walking along an association. So what we do in our code is we are only interested first in the selected fields of the first layer. So basically, from our example, this would be title and price and currency. And if we see that there are a nested selection set on that field, if there's no nested selection set on that field, we know it's basically a plain element that we can directly add to our CQN columns clause. And if it has nested selections, then we know we need to do a CQN expand. We need to go along the association and expand all the nested selections that have been performed on that field. And basically, thereby we call this method recursively to represent the whole tree that is spanned by the GraphQL query. And basically, that's all the code that is required to build a GraphQL protocol adapter. And let's now see that in action. I start the application, and I have some example GraphQL requests here. So for example, quickly closing this so you can see more. So for example, the first query that we are running here now is an by ID query, where we pass as argument the ID of a certain book, and we are interested in the title and the author. And we can run that request and see that we get the corresponding data back. The cool thing is now actually here below, we run basically the same request again, only selecting some more fields. But the interesting part is actually the header that we add here. So basically we add the accept language header here. And with that, all the localization features that CAP provides just work out of the box. So now I get this representation of the entity here in German. And this is pretty cool because actually in our protocol adapter, we didn't even know that the concept of localization existed. It's really only this thin layer that translates into CQN, and all the business logic like localization is hidden behind the service interfaces and is automatically available to the protocol adapter. Also here, for example, we are again selecting a different book in that case and some properties of that, and you can see that also our custom business logic, which adds the 11% discount, is just automatically triggered. Down here, we have another example which shows the nested selection that is possible with GraphQL. So we get here nested selection of the currency code. We can also do this with our get all query. So basically here we get now a representation of all the books and their expanded currency. And down here, we actually select something from the admin service, and this shows again that also, for example, authorization works out of the box. The admin service requires the role admin, and this is not the user. User does not have this role, only the user admin has this role in our mock users. And so we also get here an error that we get a not authorized, that we ran an unauthorized request. So if we add the corresponding user, can actually run that request and get the data back. And you can also see here a multi-level expand. So we also expanded the book at the title of the book. And for each order here, basically, we expanded the items. So the GraphQL query, sorry, I didn't show that, looks actually like this. We select from orders, and there we are interested in the items, their amount, and of the books of the items, also the title. Yeah, that's basically what I wanted to show with regards to that. Let me switch back to the presentation. So the key takeaways, the protocol adapters really act as a service client, and they just transform their protocol dependent requests into CQN. And with that, they get all the business functionality that is hidden behind the protocol agnostic services like localization, authorization, and also the custom business logic. They get that just for free. And so this really provides you with the advantage that you have a hexagonal architecture in the end of your application, and you have a clear distinction between your business core and how this business core is accessed. And now let's go to the other demo that I want to show you. And this basically now addresses the topic of with the GraphQL protocol adapter, we saw how you can easily put in another protocol in front of your CAP application, but actually sometimes you also want to put another, use certain services as a downstream service, and you don't always want to talk to an SQL database. And it's also possible to turn your services against a OData service. And this is kind of similar to what David already showed in the Node.js demo this morning. But in our Java demo here, we actually want to focus on the part how you can provide this remote service consumption, how you can provide the CQN to OData as a downstream service consumption, how you can implement that yourself using the techniques that CAP provides you. And So little disclaimer here, actually this is not supported out of the box yet in Java. So this our data service consumption, like David showed you. So basically what we will do now in the demo, we will build this feature ourselves, and with that show you how you can use the event handler mechanisms to actually do such powerful things like turning your normally SQL services into a remote or data service. So let's jump into that demo. I will quickly have to check out the branch. I will delete this here. So arrows should be gone in a second when VS Code has built the project. But nevertheless, we can already start. So what we want to do now is actually we want to add to our Fiori UI that we saw earlier, the orders UI. We want to add a shipping address selection, and this shipping address selection should come from an S4 system where we are maintaining the shipping addresses. And as David already showed this morning, the first thing that you actually need to do when you want to consume some remote API, like from S4, the API Business Partner, so you can go to API Hub, SAP API Hub, and there you can download the EDMX specification of the API Business Partner. Let's see if this works. No, my session expired again. So I will download the EDMX after I logged in. So here I have the EDMX, and I will just put that into my server module here. So basically this is the EDMX describing the full API Business Partner API. I can then run a CDS import of this external API, which will generate a season out of my EDMX. So basically the season is like a CDS model. This is the notation that we understand in CDS, and I can then import this into my CDS model to make this known to my application. And this is what we did here. We have added the API Business Partner service here to our application and also massaged it to our needs. But I won't go into details here. This is not so important for the demo due to the time constraints. So what we want to do now actually is whenever we talk to this API Business Partner representation that we have here in our application now, we want to translate every CQN statement that we send to that service into an OData request. And by default, CAP usually, when there is a service defined in the CDS, CAP usually automatically sends all the requests, the CQN statements that are sent to the service, it automatically forwards them to the primary data source, the database. But in our case now we want to override this behavior, and we can use simple event handlers for that. So here we have defined an API Business Partner handler, which registers handlers on the API Business Partner. And here in our case, we are actually only interested in the API Business Partner address entity. So we override an on handler, which is called whenever the API Business Partner address is read. And to actually know where we need to send the HTTP request, the OData request, we need a destination. And in this case, we simply configure this destination as a Spring property. And therefore, we can auto-wire it also here into our event handler. And what we do is that we run this code that we define here only if we have a destination available. And with that, we still have the ability in a local testing scenario to mock this service using our own database, using CAP's default behavior of mocking this or running forwarding queries to the database. But in case we have a destination available, we will turn the CQN statement, the read statement, into a OData GET request. And we do this by, first of all, analyzing here the columns of the CQN, and we turn these columns into a $select query parameter. And down here, we analyze the where condition of the CQN statement and basically turn this into a $filter expression in OData. So this is a little bit tricky conversion from CQN to OData. But once we have those two things in place, the $select and $filter, we can actually, using the SAP Cloud SDK, run an OData request against our destination here on the API business partner, a business partner address entity with the query parameters that we've built, and then return the data to the via the standard CAP APIs. So we basically here set the result of this event. And with that, we can now use that service in our application. So here we have another handler, the admin service address handler. This exposes the address entity of the admin service. This is an entity that we have added to this application based on the remote representation of the address entity. So also in David's demo, you saw that we actually expose the entity ourselves again. And this handler now here actually redirects the CQN statement to the API business partner service. So we make this also available here in our event handler using, again, dependency injection. We inject the API business partner service. And this can be thought of as the same thing that you do in Node with CDS connect to. And with that, we can now talk to this Bupa service. And we do this down here, and we can run select statements on this. In that case here, we extend the original select statement that comes in with another where condition that the user, the incoming user is mapped somehow to a business partner via a user attribute, and we make sure that we from the remote system only read those addresses that are assigned to the business partner, which this user that is currently using the CAP application is mapped to. Right, so let's see that in action. Let's first try to run this code now completely locally without any connection to the S4 system. So first of all, in a mock scenario. And to enable this, we have added here to our application YAML, first of all, an attribute to the admin user, business partner, SAP SE. And we have also added some mock data for our business partner address entity. Like you saw in the demo from David, we can provide CSV data in local testing to mock also the remote services. And here we have some addresses. Some are assigned to SAP SE and some are assigned to SAP US. And we've also adapted our Fiori UI, as you can see in a second. And to make sure that we have the database tables available for these remote entities, which you usually don't have in a production deployment. You don't have a database table for a business partner address because in a production deployment you talk to the remote system. But in the local setup, we want to run the database deployment with mocks. This is why we have here in our creation of the schema, which we use for in-memory databases in Java, we have added the -- with mocks option to ensure that these tables are also created. And if we start the application now.
So, Mark, I think it's a good moment for a short interruption. So we're thinking about to restart the PC with the capture card because the flickering is not coming from you anymore. It's a capture card. So we want to give everyone just 5 minutes break and then continue with a restarted capture card.
Okay, that's fine.
Yep, good. Let's pause for a moment and I tell you when we go online again.
Okay. So I hope we're live again after restarting the capture card. The flickering should be gone now, so sorry for that. As said, we will now try to run the application locally. I just started it here, and now we can go to our orders UI that we saw earlier already. Refresh that page. I also changed the language back to English. And if we create an order now, we've also adapted the Fiori UI. I didn't show you that in detail, but you can have a look at that later as well. Here with this shipping address section, and there I can click now on the value help, and I see all the SAP SE addresses because my user is mapped to the SAP SE business partner, and I don't see this SAP US test data. So I can select here, for example, an address, see also the address IDs are 100, 200, 300, and this will show up in my UI. So nothing special so far because we have just served that data from our database. But now comes the interesting part because we actually now run with an S4 system connected. And so our handler that we wrote earlier was not active because we did not have a destination configuration. But now you can see here that on the profile cloud, we now set the corresponding parameter, the CDS services APP destination parameter, to S4 Business Partner API. And we've also made the credentials for this S4 connection available in our environment. And now if I run the cloud profile of this application, and once it's started, go back to the UI. I quickly refresh here to make sure that all Fiori caches are cleared. I can now click on the create button, and actually now I get 2 different addresses. Those are actually read from the S4 system, and I can now select one of the addresses that is available in the S4 system. And similar as before, this data is also replicated here. And once I add the order number, I can also save this draft here. So similar to what we saw in Node.js, we basically saw that we could just replace the destination or include the destination, and with that, our application suddenly started talking to a different downstream service, to a data service. And the key takeaways from that are actually that the event handler API is really flexible and can be used to define the behavior of a service, and that this gives you the advantages for your application that you only have one query APIs, and with that your consuming service are not coupled to the underlying infrastructure. So the address service, admin address handler, it did not know if the data was served from a database or from a remote or data system. And we are currently working on providing this capability out of the box. So in the future, you will not have to write your own CQN to OData transformation. But this basically, with this, we wanted to show the point that this is possible already now. And with that, I would like to hand over to Adrian, who actually wants to show you a different protocol that you might want to use as a downstream service. namely a demo for a MongoDB data source adapter. So with that, it's your stage, Adrian, again.
Okay. Sorry, I need to share my screen again. So I hope you can see my screen. Thanks, Marc, for these two demos. I want also, as Marc mentioned, demo how to can use our modularization features to connect to something completely different, namely to a MongoDB database. So quick, I must admit that I'm not super knowledgeful well, with MongoDB, but nevertheless, I created a slide to quickly summarize what we're talking about. So MongoDB is a general purpose database, but it's completely different than a relational database. It's a NoSQL database. It's very importantly schemaless, and it's a document store. So you can, it's really designed to, well, store deeply structured documents. And therefore, it also has a query language which is designed to query deeply structured documents, which is a bit similar in style to the GraphQL language which we have seen. Basically, queries are expressed in, well, as something called BSON documents, which you can then execute against your data store and get then again a deeply structured result. And then, of course, one of the key features of MongoDB is that it's a distributed database, which can very nicely scale out, of course. So when converting CDSQL to HANA, then the expectation is that some things which are very easy to achieve on HANA, like expressing views or joins or subqueries or projections, that they are actually pretty difficult to achieve on MongoDB, where other things which are easy to achieve, which are complicated to achieve on Mongo, like, for example, to implement an expand or to do a deep insert, or cascading delete would be fairly easy, or to convert path expressions to joins. Such tasks are then again very easy to achieve on MongoDB. So therefore, what we are going to see here is something which we are currently developing in-house for a team which is going to use MongoDB productively. The disclaimer, though, is that we do not have any clear, well, statement or conclusion whether we want to offer this then as a productive offering at any time. Okay, so how did we proceed? So first of all, I have a very, very primitive application. It basically has, of course, the model is captured by CDS. So we have here persons with first and last name. And then we also have orders, again, extremely primitive. Basically, it has a date attribute, but it also has a composition of items. And the items then have something like amount. The other associations here we need to ignore, unfortunately. And then my application also has, again, extremely primitive business logic. Namely, the only thing I want to do is whenever I read a person, after I have read the data of the person, I want here to concatenate the first and the last name to the basically to calculate the value of this virtual element name. Now we decided when we implemented this adapter for MongoDB that we want to do it in a way that we directly implement this interface CDS data store, which is also used by the auto exposure or by the generic CRUD handlers of the CAP Java stack to execute queries. So we just wanted to make an alternative implementation of the CDS data store. So this basically has methods like execute a select statement or execute an insert statement, and for all 5 statements types which we basically have execute methods. Interesting part is now the Mongo is now the MongoDB data store. So this implements here the CDS data store interface, and so actually the only thing that we have to do is to take a CQN select statement. This is the in-memory representation of the CDSQL query, which I mentioned earlier, and convert this then to the Bison query language required by Mongo. So the tricky parts are obviously to convert the filters, which the select statement might contain in the where clause, and to convert the projections which the select statement might contain in the columns clause. So if we look into filters, the filter in CDSQL or in our Java stack is basically represented in memory by a CQN predicate. And what we do here is that we define a visitor with which we traverse the CQN predicate, which can of course be something like an expression tree. And then, for example, when we visit a comparison predicate, we then convert it to the corresponding Bison snippet understood by MongoDB. And if we hit something like an and or, we basically then convert it to the corresponding Bison construct, which corresponds to and or on MongoDB. So this is actually really very straightforward thing to do. With projections, it's also, I mean, we already earlier have seen examples by Marc, for example, in his GraphQL example. What you can express in CDSQL are expands and nested expands, and also you can specify a select list. So basically the only thing which we have to do here in order to convert this select list here to something, to a Bison statement understood by Mongo, is that we have to, very, very similar to what Marc did with GraphQL, we have to iterate over all items and then recursively expand basically the nested expands. So when we if a select list item is an expand, then we recurse into the very same method. And if it's like, elementary element which is on the select list, we can just add it to the corresponding Bison construct. And this is all which we need to do here. Now, having this said, we still only have an implementation of the CDS data store with Mongo, which basically can convert CQN queries to the corresponding Mongo constructs, which we can then execute against the Mongo database by fetching the collection and then applying the filter, applying the converted projection, and here we're also applying top and skip. But still, it's just the CDS data store implementation. Now we want to register it, and the way we register it is as follows. So currently, unfortunately, our CDS Java stack is not at the stage where you could completely completely define your own persistence service from scratch. The only thing which you can do, but this is again already extremely powerful, is that you can basically replace all the default handlers of the persistence service with your custom implementation. And this is what we did here. So at runtime, we basically register a string bean of a CDS data store connector, which we then inject here in our MongoDB persistence handler. And in the MongoDB persistence handler, we basically replace with add-on all the default handlers of the persistence service, which a handler which executes then via our data store connector, via the Mongo data store connector. So what the code here does, it extracts the select statement from the CQN, it projects it down to the underlying, this is as we have like to the entities of on domain level, and then via this data store we execute the select statement. Here on my machine, because we also want us to see this, of course, running, I do have Docker running with a Mongo database, so I'm not using internet scale hyper large Mongo, but only a tiny one on my Docker container here. And the application is not running, so I need to start it. I still wanted to show, I guess, yeah, yeah. So for persons, the data is automatically filled in by a CSV file, which I have in the data folder. So therefore you will find like pre-deployed data. If I start the application, something should happen. So Spring fires up this application now. Now I should be able to run OData requests against this application. So for example, this one here. You should see the result here on this side. So as we have like this orthogonal architecture now, it's completely decoupled which protocol adapter I'm using. I'm using here the default built-in OData v4 protocol adapter, but by replacing my the default handlers of the persistence service, I'm redirecting them to the MongoDB. So here I get a result. I could, as we've seen in the implementation of projections, I can, for example, apply a projection filter by first name here. So I get besides the ID, only the first name in the result. In the next example, I apply a filter larger than Emil, so I should not get Abel, for example. No. Sorry. This did not work. Okay, I need to fix this.
So, and perhaps before we start into fixing the issues, just a reminder of the time, because there are some questions, and perhaps you also want to do a wrap-up.
Yes, absolutely. Okay, we have time until now, right?
Yeah, but we do 5 minutes more due to the break for the capture call.
Okay, but so maybe my wrap up for the Mongo implementation is this is really work in progress. It really turned out the expectation which I outlined here, that some things which were in the SQL implementation really tricky to achieve, like the expand or a deep insert or a deep update, they are very easy to achieve on Mongo, while as for other challenges, for example, how to implement views or to associations to other structured documents, we are still in the phase where we have to evaluate how to achieve this most conveniently or best. Also, it's important to note that if you really plan to run CAP on Mongo, you might have to keep in mind that you pay attention when you're modeling the model of your application that is really suitable for Mongo. So Mongo works really well for compositions, for everything which stays within a structured document, and you have to make sure that you really leverage this feature very well. This is maybe my wrap up for Mongo. Then I would like actually to hand over to Marc again, because we still have some platform-specific modularization features which I'd like to mention very briefly.
Yes, maybe very quickly we can go over these last 2 slides. Maybe I also skip one. So basically what we also wanted to say that in CAP we also have one further concept to provide modularization. And this is actually when it comes to platform capabilities. And when I'm talking about platform capabilities, I mean something like authentication or how you get access to service bindings. And in CAP Java, we have for this optional components so-called features, and they usually integrate services that are provided by the platform into the app. And what we do in CAP, we usually provide implementations for that for local development. So for example, for authentication, we provide the mock users side by side with the XSUAA approach, which we use in Cloud Foundry. But this makes it possible to abstract on these platform features and also have the ability to run your application easily locally, and also to protect investments into the core of the CAP framework. So if you maybe change the authentication strategy, this is not tightly coupled with CAP itself. Basically, this can be exchanged then also through a reuse component. I will not go into further details here, I think, because we also have some questions that we would like to answer. But at that point, yeah, thank you for your attention and for staying with us throughout these presentations. And Gregor already replicated some of the questions into our teams here. So maybe one question that he said was discussed quite frequently in the chat was an issue that we have currently with the CAP Java stack with the artifacts that we published to Maven Central. In fact, there's one artifact that is referenced by the CAP Java stack currently that is not published on Maven Central. It's only available internally at SAP. We are working on getting this dependency published, but in the meantime, you might observe issues when running CDS init with option Java. That once you run the Maven build, that it complains that some components are not found. And yeah, the recommendation currently is that this component that is not found can be simply excluded from your POM. You can have a look at our example project at the bookshop that we showcased earlier. We also excluded this dependency there, and I think Gregor also mentioned that commit in one of the issues he linked. So this is unfortunately currently still required to get your application running using Maven Central only. And we are working on fixing this. We are aware of this issue, and it's bugging us for quite some time now already. And I saw, I think, another question. Yeah, there was one question in regards to overwriting add-on handlers. So the question was, if I overwrite my on handler, then suddenly all the filter capabilities and stuff like that, they do not work out of the box anymore. Yeah,
So maybe I guess I was hoping to showcase how to override add-on handlers. Via the CQN select statement, you basically have access to all the filters and top and skip and so on. Although now in this quick demo, the filter for some reason did not work. But basically everything is there. You only have to pay attention that you access the information and evaluate it then from the CQN select statement properly. We are working currently on documentation, how to describe this in more detail, to give better examples. You have one option is to do what I just showcased, to use the CQN visitor to extract the information. Other way to tackle this would be to convert the statement to its token stream and extract whatever you need from the token stream. And thirdly, we have something like a CQN analyzer, which helps you to extract, let's say, filter values from a filter predicate. This can also be helpful, but just stay tuned. We will working on a chapter in the Capira documentation on this topic.
Excellent, excellent. Also, perhaps let's use it as a last question. How can you add this API key, which is needed if you want to use the sandbox service from the api.sap.com? Is there a way to bring that into the request?
Yes, this could be easily brought in. So you could think of having that also as a Spring property, for example, and when doing the Cloud SDK call at the end, using the OData client of the Cloud SDK, you can also add additional HTTP headers to that request, and there you could provide the API key.
Okay. Yeah. Maybe just a neat idea for the sample application to actually use this.
Yeah, this is actually a good idea. Yeah, I was actually not much aware of this, that this is available, but it's a good point. So you don't have to have an S4 system to run it.
Yep.
Also
Excellent.
with a remote data system. Yeah.
Good.
Thank you.
I only can thank you very, very much. And also the clapping from the chat, relying that. Adrian and Marc, great mix of giving us the theory and also the practical demos, and a lot of stuff learned regarding the integration of different data sources and also protocols. Very nice. So we will continue, I think, punctual at 15:45 CEST, and see you there.
Thank you. Bye-bye.